Happy Summer Solstice! Today, June 20th, is the beginning of summer, also known as the Summer Solstice. For those of us in the Northern Hemisphere, today is the day when we have the greatest duration of sunlight. Over the course of the next 6 months, the amount of sunlight that we have each day will get progressively shorter and shorter until we reach the winter solstice, December 21st, the beginning of winter for those of us in the Northern Hemisphere. Long before the invention of smartphones and even the invention of mechanical clocks, ancient people used the position of objects in the sky to help them tell time and their location on the surface of the Earth. The sun appears at its highest position, or altitude, in the sky on the summer solstice. Now, if we track the sun every day at the same time, let's say at around noontime, we will see that over the course of the next 6 months, the sun will get closer and closer and closer to the horizon. Calendars help us keep track of time during the year. An analemma calendar tracks the path of the sun in the sky during the course of a year. This is the analemma for us in Cleveland, Mississippi. It tracks the sun with the sun at its highest altitude on the summer solstice, sweeps down, and then goes back up again, tracing out this beautiful figure 8 pattern. You might find an analemma on some old globes, or even as a sculpture, working in a similar way as a sundial. Many cultures erected monuments to help them mark time. Stonehenge in England was constructed around 3000 to 2000 BC to align with the sunrise of the summer solstice and the sunset of the winter solstice. The Earth's tilt on its axis of about 23.5 degrees is what gives us seasons. During Northern Hemisphere summer, the Earth's northern hemisphere is tilted toward the sun. This results in the sun appearing higher in our sky, and sunlight strikes the Earth's surface more directly, leading to warmer weather. While we experience summer in the Northern Hemisphere, the Southern Hemisphere experiences its winter. And the interesting thing is that you have to have a tilt of your planet to experience seasons. For example, Jupiter only has a tilt on its axis of about 3 degrees, which means that Jupiter doesn't really have much in the way of seasons at all. While we're talking about the sun, let's also talk about eclipses. Total solar eclipses occur when the moon passes directly between the sun and the Earth, perfectly blocking out all of the light from a sun's surface. But an annular eclipse occurs when the moon is just a little bit further away from the Earth than it is during a total solar eclipse. During an annular eclipse, you see a ring or annulus of the sun's light around the edges of the moon. Now tomorrow, there is going to be an annular solar eclipse that tracks across a portion of the Earth's eastern hemisphere. This is what the annular eclipse will look like from Addis Ababa, the capital of Ethiopia. For a few moments, it will get dark enough to see Venus, Mars, and the star Sirius during the daytime. The last total solar eclipse visible in the United States was on August 21st, 2017. The next one that's visible in the United States won't occur until April 8th, 2024. It's not going to occur anywhere near Mississippi, so you're going to have to plan in advance and make a journey if you want to catch that eclipse. Thanks for watching. Today you learned about the summer solstice, the beginning of summer, the solar analemma, the reasons for seasons, and eclipses. And I hope to catch you again soon on one of our Wiley Planetarium astronomy videos.